In front of the camera, but since you have the mic.
Allah, let me introduce you. Person who needs no introduction here, but as you can see, we are quickly approaching the climax of the workshop, and to guide us through that transition is Mark Feldman from Stanford University, who will give us 4 perspectives on transitions in evolution.
First of all, I wanted to thank the Triumvirate for asking me to come. Always a pleasure for me to come to Israel. I gave this title because there are 4 possible subjects that I've been working on or have worked on that may be related to what the organizers wanted to talk about at this meeting. And they fall into the following categories. The first one is, I call it the evolution of resilience. And that is basically a paper that came out earlier this year with colleagues from the Department of Computer Science at Stanford. The second one concerns a study that I did with 2 outstanding undergraduates at Stanford on properties of the Y chromosome. The third one concerns some research that is about Taiwanese Aborigines and may seem at the first glance not to be related to what else has happened here, but I think it is, and I'd like to get your perspective. And the fourth one is something brand new, research that I've been doing with Yoav and a new PhD student at Stanford named Caleb Benton. So the first topic, the evolution of resilience in protein interactons across the tree of life. Marinka Zitnik, a postdoc in our computer science department, just took up her first faculty position at Harvard. And this is an analysis of a very large database. The database consists of these, I'm going to get used to this, consists of these data that address 1,840 species, from which we have more than 8.5 million protein interactions, connecting 1.5 million proteins. Of the species, Paul will be very happy with this, with the balance of bacteria to everybody else. But it just happens that when you're looking to get complete protein interactomes, it's not easy to get them from species that aren't bacteria. So we got, as of 2017, we have all of the data that have been published on protein interactions, protein-protein interactions. Now, each species is going to be represented by its protein-protein interaction network. And I would like to imagine that this has to do with what Paul was talking about earlier today, about process. It may be that it doesn't, but I think it's a reasonable way to start to discuss evolution in terms of process. Everybody knows this stuff about a network being a set of nodes and a set of edges. And the nodes are the protein-protein coding genes, and the edges are the protein-protein interactions. Now, what we've defined here is something that hasn't been used in molecular evolution before. It's a thing we call resilience. And if you have a network which comprises all of these protein-protein interactions, and you make a removal of a fraction f, that's like the failure rate of the network. Now, you calculate the Shannon diversity, which is a classical information measure, on the resulting fragmented interactome, GF, by taking the K isolated components. So each of these C's is an isolated component, which is an interactome of size n. You then compute the usual information measure, classical measure from electrical engineering. That's this thing here. And the PI is simply the fraction that's involved with this component. The resilience measure is 1 minus that integral from 0 to 1, where you're integrating over the fraction that were removed. Now H, this measure we call H, if you consider the interactome of, say, influenza, Haemophilus influenzae, it fragments very quickly with F. It breaks into pieces very rapidly. On the other hand, we take the human interactome, what has been published of the human interactome, it doesn't. It stays together until F becomes quite high, this fraction of the proteins that its family. In other words, it's resilient to removal or breakdown of the network. Now, I would put it to you that this is a reasonable way to look at the continuity of transitions. And how you might ask, what's that got to do with evolution, is you go to Hunt et al., 2016, who has the latest version of the Tree of Life based on short ribosomal RNA, short subunit ribosomal RNA sequences. And you look at that tree and then compute the evolutionary distance between the various points on that tree and ask, how does that relate to the interactome, to the resilience? And it turns out that there's a very strong correlation between the evolutionary distance and the resilience. So I put it to you that there's a reasonable way to make a continuous view of what's going on through the protein-protein interactions as a process of evolution. The connectivity, on the other hand, is not much affected by small random failures. This is really another very interesting part of the computational stuff that was revealed here. Now, because there are so many bacteria in this database, we can actually make a fairly confident statement that bacteria with more resilient interactomes have significantly more regulatory genes in their genome. We can also ask, what's the ecology of the organism got to do with the resilience? And bacteria living in the most complex habitats seem to have the highest resilience. In other words, aerobic bacteria have by far the highest value of our resilience compared to all the other bacteria. Host-associated bacteria have the lowest resilience. Now, overall, it looks as though these resilient interactomes can harbor a lot of neutral mutations with no ill effects. So that's the first thing that I would put to you, is related to the possibility of quantifying the process of transition through the tree of life using protein-protein interactions. Now, totally different. In the Neolithic replacement, which we heard about yesterday, of early Europeans, we have a process that everybody agrees happened roundabout between 9,000 and 12,000 years before now, of farmers who came across from the Middle East, probably from Anatolia, and overwhelmed the resident hunter-gatherers. That's the classical view. Now, in our study, we used data that came from ancient DNA sequences of Europeans carried out in the lab of David Reich and other people, particularly the Leipzig group. And these two phenomenal undergraduates working with me, he just finished at Stanford, he's now a PhD student at Harvard, and Alan is now a PhD student at Berkeley. And the issue was really an interesting issue. It brought up in the data that we analyzed from these 4 papers. I'll show you the bottom line of that data, which is hard to believe. Here is the time scale, thousands of years before now. Thousands of years before now. And these estimates of the population size of the Y chromosome and the mitochondrial DNA use a package which is used everywhere in molecular evolution called BEAST. And what it does is it puts in an estimate of mutation rates, and the population size is estimated from the coalescence time of the various sequences that have been put into the database. Now here's what happens. For the Y chromosome, you see this drop here around about 5,000 years ago, close to 5,000 years ago. This is from Carmen et al. Out of David Reich's lab. But look at the mitochondrial DNA, has no such drop. So the bottom line from this is that if I take the ratio of the number of females to males at that point in time, which is estimated to be between 6,000 and 4,500 years before now, we have this massive female bias, a factor of almost 17. 17 times as many females as males, based on the Y chromosome and the mitochondrial DNA. How can that be? I mean, it's pretty absurd to say that there would be 17 times more females than males at that time. And that's what led us to ask, perhaps it's not exactly the way in which people envisage it, but maybe there is competition between the cultural descent groups that are based on Y chromosomes, and how would we go about modeling that? Now, the well-known facts now, they weren't so well known a couple of years ago, are that there was a massive migration of people from the Pontic steppes of Russia at about this time, about 6,000 to 4,500 in that space of time, who came from there, and they had an innovation. They had horses. And they overwhelmed the resident Neolithic farmers who didn't have horses. And that's where horses were domesticated in the steppes. So the possibility is that these patrilineal groups that came in showed this cultural identity defined by being Y chromosomes and therefore being corporate groups. Now there's a precedent to this, and this is Evelyn Heyer, who is at the Musée de l'Homme in Paris. And I cite this for you. Pastoral populations exhibit a substantial loss of Y chromosome diversity in comparison to farmers, but no such difference is observed at mitochondrial level. Our analyses indicate that the dynamics of patrilineal descent groups, which implies different male and female socio-demographic histories, is responsible for these sexually asymmetric genetic findings. So that's been well known, and this is based, by the way, on data from Central Asia, from Kyrgyzstan, Uzbekistan, Kazakhstan. That's where she does her fieldwork. So how did we go about this? This is a massive simulation study. We postulate that there is a continuum between patrilineality, low intra-group diversity, and competition removes diversity. So if we have a set of HY chromosomes, I'm going to call them H because we use the term haplotype to describe the genomes of the Y chromosome, and we have this many culture groups. In fact, we choose 500 of those and 100 of those for our simulations. So if the culture groups are in fact Y chromosome groups, then they're on that line there, that diagonal line there. On the other hand, if there's no patrilineal distribution, then it will look scattered all over the place like that. That's where the cultural groups and the haplotypes have no interaction with one another. So what we're going to do is to simulate. Now, those of you who want to see this slide, you can shut your eyes for the time being if you don't want to. This describes the simulation. For those of you, it's going to be on the computer here. Just to mention that you have a large population size partitioned into that grid. We simulate over T generations of competition with probabilistically defined competition, adding mutation of haplogroups, but keeping the total population size fixed. And that's basically what's going on. The rest of it are details of how the simulation is carried out. These are the results of that simulation. We do 100 replicates of every simulation. And what we find is that if you count the number of individuals here, and it goes from 0 to up to 10,000 here, and these are the amounts of diversity in the Y chromosomes that you can see, in the haplotypes. So what you see is a massive loss of diversity in the Y chromosome due to the competition between the cultural groups. It's actually based on competition between the culture groups, which eliminates most of the Y chromosome variation. So it doesn't have to do with males and females being imbalanced. It has to do with the cultural competition that is going on in this process. And it doesn't depend on how hard the competition is. This is what happens in the non-patrilineal case, where you don't have that competition. A totally different distribution of the Y chromosome hitchhiked cultural diversity. It doesn't matter whether we double the population size, where we change the parameters of the model, you still get pictures like this. You still get the same pictures. It's really, really quite robust to those different parameterizations. So that's the second topic, that there is this transition from farming to Yamnaya farming is an important transition, because our knowledge now of the genetics of European farmers is much more biased towards Yamnaya than it is towards Anatolia, which is where the original Neolithic people came.
Mark, but so you're saying what kind of reverses you interpret
interpretation of the earlier paper? Or?
Well, yes, it does. I mean, it says that we now have to really focus on Yamnaya rather than on Anatolia for the current situation in Europe. And that was the statement also made by Carmen et al. From their analyses, which they didn't do any modeling, but based on their data analysis. But this is providing a process and a reason for why their data came out the way it did. By the way, it doesn't say very nice things about how they treated females, right? But that happens in every example of colonization that we know about today. Going back to the conquistadors in South America, going to the British in Australia, that if you look at the indigenous people, their Y chromosomes are overwhelmingly those of the conquerors, and the mitochondrial DNA are distributed mainly among the indigenous people. So that sort of thing is just a symptom of colonization. Now I'm going to give an example of a transition that happened not very long ago that possibly nobody could have predicted. This comes from work that I did with Melissa Brown from the anthropology department, who has been studying China for quite a long time, and in particular, Taiwan. Why Taiwan is really useful is because it was colonized by the Japanese in 1895, and the Japanese have meticulous demographic records. They have complete censuses of Taiwan from 1895 to 1945, when it was taken away from them and became relatively independent. They have what we call hatches, matches, and dispatches, the marriages, births, and deaths of every single person on the island. They ruled with an iron hand. Now, the first Chinese that came to Taiwan, mainland Chinese, came from Fujian province in the southeast, and some of them were Hakka, and there's a lot of Hakka culture there. And there was a subsequent migration from the south of China during the second half of the 19th century. So there's a lot of indigenous people there waiting, not with bated breath, but waiting for the Chinese to come from the mainland. The people who were there before them were Aborigines. There are different tribes of Aboriginal people who share a common ancestry with many of the Melanesian islands and have some of the same customs, such as they painted moustaches on the women. They tattooed moustaches on the women. And it's really quite interesting, because the only people now that do that are the Ainu in Hokkaido, in the North Island of Japan. So, very interesting things. These Chinese who came were part of the mainland culture, and they bound the feet of women. When girls were sewed up like this, a terrible custom of binding feet so that it broke all the bones in the baby's feet. That meant that they couldn't walk outside the house. They had to work inside the house, and they did weaving primarily and sewing. And they had these different types of feet that all of them are appalling. And in most of the museums in China now, you can see these little shoes which are exhibited to show exactly what cruelty it was to the females. Now, 1895, this is the situation, and 1915, the Japanese passed a law for Taiwan that foot binding should be prohibited. And the reason for this was they needed more production of food. So they wanted the women to be able to work in the fields, while more of the men went into infrastructure development, roads, bridges, and that sort of thing. So foot binding was outlawed under very strong penalties if you didn't do it. Now this is a really very interesting fact because the Chinese viewed the Aborigines as complete barbarians because they didn't bind the feet of their women. And there was, the Chinese had a marriage situation which is commonly called very local, where the girl has to move to the house of her husband-to-be and becomes the main working person for the people in that house. She does the stuff for that household, her husband's parents. And throughout China, this has been the case for thousands of years. And it was the case in Taiwan. You had very little what is called local marriage, where the boy moves to live with the girl's family. Now, here is the situation in 1906 to 1915. This is a fraction of local marriages among Aborigines who had no such custom at all. They essentially married just the way in which Westerners do today. From 1906 to 1915, from the Japanese data, we have exact numbers. And so we can tell how many local marriages there were. Up to 35% of the marriages were local in the different Aborigines. But these are the Han, the Chinese. Over the next 30 years, we see that there's a cultural drop in the fraction of local marriages, drops almost a few percent. And the correlation seems to be inescapable that the banning of foot binding had to do with this change of the marriage customs. We can't find any other correlates, except I'm going to show you a few things that happened alongside this. During that period, the shaman, who was called the spirit medium, who was always a female historically in that group, no longer becomes female, changes over to be a male. We can find, interviewing the last woman who was the shaman, couldn't find the female replacement. No females would take the job because once you do the very local marriage, you become the property of the husband's family and you can't go out doing independent work like being a shaman. You've got to look after the children, which didn't happen before. The shaman were really quite important people, the women. In addition, you have this change of religious practices that the Aborigines start to have incense burning. They start to clean the grave sites, which they didn't ever do before. They put up all these sorts of ornamentation, which is classical mainland Chinese. So what I put it to you is this transition that happened in these customs was brought on by the foot binding ban. And it's, I think, an example of epistasis, or you could call it cultural niche construction if you like, but it's an interaction between two different sets of customs. Now, the last thing I want to talk about is new work on the evolution of conformity. Now, much of the work on evolution of conformity takes as its starting point some parts of Boyd and Richardson's book, which really, the 85 book, which takes a rather different approach to mathematical theories of cultural evolution, and then Cavalli and I developed 15 years earlier. This approach, which I'm going to show you for one of the sections of their book, I believe is at best incomplete. So this is a definition of conformity. A social learner exhibits conformist bias when the probability that it will adopt the majority trait exceeds that of the frequency of the trait. So that would be bias, conformity bias. If it went the other way, you'd call it anti-conformity bias or minority bias. So we have a few questions that are really interesting about that. And this work that I'm going to describe to you now is being done together with Yoav and my PhD student, Kayla Denton. So the first question you might ask is how to model it in terms of the number of models that you have to conform to, the type of selection that might be happening while this conforming is going on. Is the population subdivided or not? We have to look at the features of the dynamics of whatever trait you're interested in. How does the general pattern of social learning interact with conformist bias? What's the relationship between conformity and cooperation? And how do you decide whether there's going to be conformity or anti-conformity evolving? So this is taken from their book, from Boyd and Richardson. And this is where one has a situation of 3 models. Every individual looks at 3 individuals in the previous generation. These individuals can be of one of 2 types, C and D. And the probability that that offspring acquires the trait, the cultural variant, depends on this parameter D. Now, if D is bigger than 1, then you've got a higher probability of adopting the majority trait. So D is a parameter that defines conformity. The next step is to say, how does the formation of the population by sampling, how does that happen? Well, you use a binomial probability here, where this P is the frequency, let's say, of little c in the population. So after the transmission by this matrix that we just saw, the new frequency is this, which reduces to this rather nice thing here, reduces to a very simple formula. And this is the formula that most people associate with the evolution of conformity, where you have 3 models and a dichotomous trait. So the question is, what happens to the evolution under this system? Now, what happens if you have 5 models instead of just 3? Every individual now has to learn from 4 parents or 5 of the parents. And these are not vertical transmission in the classical sense. They're closer to oblique transmission in the sense that Cavalli and I first used and that Yoav talked about this morning. Transmission from non-parents in the parental generation. Now what you notice here is that with 4, you get exactly the same dynamic as you had before. With 5, you can't write it down in terms of 1 conformity parameter. You need at least 2. So we put in 2 conformity parameters. Now, I emphasize this because that will play a huge role. And all of this work I'm going to tell you about is in progress. And we've discovered some very interesting facts. First of all, there will be constraints on the conformity parameters because you want the probability of being a big C or a little d to be between 0 and 1. And for that, you need these constraints. So depending on how many models there are, you get a different set of constraints where as you increase the number of models, you increase the number of parameters that you have to use to describe this model. So as you have a transition from copying very few individuals to copying very many, you need to have a much more complicated set of parameters to describe the evolution of conformity. Now, what I'm showing here is the dynamic when you have 5 people that you will copy to get to your state. And with 5, I just showed you, you needed 2 parameters, this D3 and this D4. So we picked 2 values of D3 and D4. And what we see is amazingly interesting and highly unexpected. What you see here is that if this is the dynamic where I plot the frequency of in the next generation against the frequency in the present generation. As you go up here, it's monotone increasing transformation, this recursion system. And what we see is that this 1/2 here is unstable. The eigenvalue is bigger than 1. This is unstable. The eigenvalue is bigger than 1. That's where you have 100% of little c, 100% of little d. The eigenvalue is bigger than 1. So none of the equilibria that are in Boyd and Richardson are stable. In fact, there are 2 other equilibria here that are the stable points. So the first step that we know now is that as you increase the number of individuals that you're going to copy, the dynamics are going to change, and they're going to change in very interesting ways. Now here's an even more interesting thing. I'm going to plot the same thing, the frequency in the next generation against the frequency in the present generation with 2 other values of the 2 Ds. Now what do you see here? Well, first of all, this is the fixation of d, little d, and the fixation of little c, both unstable. Now this is the remarkable thing about this, that this also is unstable. Now there are no equilibria in this system that are stable. There are no stable fixed points. And this is the first example that I know of in all of this kind of modeling where there are no stable equilibria. Now we know examples from other dynamical systems, of course, where you can get cycling and that sort of thing, and even chaos. So what's next? When you see this and you see these 2 bumps here, it leads you to suspect something's going on. So what do? Instead of plotting every generation against the previous generation, we plot 2 generations against the previous generation. So we now have a step size 2, and what we see is those 2 places where those maxima, the critical points, were before, they are stable equilibria. So they're stable of the cycle. So you bounce back and forth every 2 generations between those 2. So it's this. You can't find anything about this in Boyd and Richardson's book. It's a really unexpected thing that we did not know about before in that relatively simple dynamic. So the results, which I can think are quite remarkable, are that it's possible to have no stable equilibria of the dynamic. It's possible to get a 2-cycle here. And when the conformity parameters are of different signs, when you have greater than or equal to 5 models that you're copying, you can get at least 3 polymorphic equilibria. Unsolved problem. Can you get more than 3? We don't know that. We haven't discovered that in any simulation so far. Cycles are, of course, I just showed you, are possible. And as of last week, we found a very interesting property. I'll go back to this equation here, and then go, you see that there's just this p equals 1/2 is an equilibrium here, p equals 1, p equals 0. They're fixed points of the system. Now when you go to 5, you have all this stuff over here, which is going to make a big difference. So it struck me that if you have this stuff in the system, then maybe you don't have to have any equilibria or any cycles. And if you remember, if those of you who are ecologists remember May's book and the description of chaos, when the birth rate gets to be very high in a discrete logistic equation, this is a logistic equation, except it's multiplied by this function here, 2p minus 1 times that. So if that thing gets to be very big, I suspect that you're going to have chaos. And the last thing that I'll leave you with is, in fact, that's true. So as you increase the number of models, you can get chaos with the right choice of those P's. So all of these new findings for evolution of conformity, they're basically brand new. And we're following up, and your author told me that he's following up from both the network approach and the prestige approach. And it looks to me like it's going to be really nice. Thank you.
Thank you very much. I would like to add a comment to the first perspective. I think that's a very useful suggestion to look at these interactome patterns, in all the different kinds of transitions. It reminds me of one work that we did together with Barabashi and some other people in 2001. In that work, we looked at the metabolic network, not the interactome, but metabolic network of a number of species in bacteria, archaea, and eukaryotes. And we were looking at the system level properties. And one result was that although it's known that the metabolic enzymes in the eukaryotes today are coming from the bacteria, but if you are looking at the eukaryotic organization of the metabolic network, it's archaeal. So it's striking. So the archaeal organization of the metabolic network put a constraint on what kind of enzymes were adopted from the incoming bacteria and at what position. So that shows that it's really can give answer this network perspective to things that are relevant to this transition issues. But of course, that was 2001. So I guess, thank you for reminding me, because I think it's time to have another look at these things with the new data and the new methods.
I didn't mention several of the things we did there, but when you look at the network itself, you can look at the motifs within the network, and you can ask how complex are those motifs, and does the frequency of complex motifs increase with what we might call complexity of the organism? The answer is yes, there's a very high correlation.
I was just reading the paper on the interactive. How did you took the big genome sequences, you took the proteins, predicted, and then you took all the publicly available interactive.
Yeah, all publicly available data on protein-protein interactions, and I was sure something that have some RNA data from the tree that we published, or a new tree.
And the resilience you got from
that's purely computational.
Right.
Yeah. Just seeing what happens to the network when you cut on this.
Okay. Since we're actually also running out of time again, I think we'll just finish this and continue. So let's thank you.
How much can you have?
So in an abrupt change, we move from one phase to another. In the first phase, most of us were passive, and each time in turn, someone else presented. In the current phase, we all need to be active. So it was said several times during this conference that we are super cooperators. Let's see if we can do it right. And towards that end, I asked Ayelet to help us in that in order to facilitate the next phase. Okay, so I will serve as the right hand.
אני רוצה להציג את
את מה?
תציג את הסכמה הכללית, ואז...
Okay.
The general scheme that I would like to present is not the content, is the framework, is the technical way to work to make us productive. Okay, what I have in mind is the previous experience in a similar practice where we got in a workshop people that we did not know, most of them did not know each other. At some point we split, can't remember if it was a bottom up or top down, but we split to 3 groups, and each group worked for a while on their own thing, every now and then reporting to the larger team. And it ended up with at least 2 of those 3 groups producing something valuable and novel. And that's what I had in mind. So the general framework would be that we now discuss, try to open several open questions that are worthwhile of discussion, and perhaps delving into data and looking into or developing models, whichever method we choose to attack. But at this point, we are not going to be exclusive. We only try to add items into a list of plausible subjects for discussion. Then we will discuss these issues together with Ayelet. We take a short break for a little bit more coffee. And during this break, each one of us is asked to put their initials, okay, in those subjects that they like most to participate in working on, okay? We hope this would form teams of anything between, I said 1 these days, maybe 1 is a little too little, but anything between 2 people in a group, in some cases perhaps 1, and up to, I guess, 8, or whatever happens.
So the idea is this, we invited you to a workshop with a question, right? Is humanity going through a major evolutionary transition? And it looks like for most people the answer is no. But what we thought, that was just a provocative way to draw you here. And the idea is to come up from the different knowledge and specialities that we have here, to come up with the tools in order to, and come up with some common language, operationalizations, common questions, common themes, in order for us to be able to have some tools in order to have that discussion in a more informative and practical way, not just give a yes or no answer, okay? And so the idea is this, we ask for questions that Ehud and Yochai and me, we sat before yesterday and today and came up with some questions that we thought resonate, some common themes here, common questions. But first, we would like people sitting here to suggest what kind of questions seem interesting to you in order to advance discussion that would resonate outside this room. Okay? What are the basic questions or types of models, operationalizations? How can we advance? How can we make a more informed discussion about evolutionary transitions about humans? And sometimes in order to make a discussion about humans, you don't need to talk about humans. You can use tools from ants, from wasps. You can use mathematical models okay? Yeah. So if you have any suggestions for groups to continue the thought in a more active way. I didn't put it right now. Sorry.
Another question, but just.
I still can, like,
Maybe a comment that provokes some more discussion. It's clear from discussion that I think we have different ideas about what individuality is, what transitions are.
Right, so I'm just writing, because you see, one of the questions we thought that would be really interesting to come out of this is what is individuality? Okay?
העלית, אני כותב את זה פה.
So,
בסוף מעטי.
I was going to say, you started off saying that it seems that most people in the room thought that human society was not undergoing a transition in individuality. Of course, that begs the question of what do we mean by that individuality? And I think the people that said that human societies like Dan and others are not undergoing a transition in individuality are looking at the problem from the perspective of units of selection, whether so they're thinking about individuals as entities or collectives that participate in the process. So from that perspective, I'm among those that would say it's likely that humans are undergoing evolutionary transition. But that's based on my definition of what level is, what transition is, and what individuality is. And Ava made very clear, and others too, that there is a whole other sort of set of perspectives that are possible on what individuality is that is particular to humans. So I wonder if it's useful to be clear about what we are talking about here, not before we go on to define the topics for further discussion.
so,
Because I'm sympathetic to both perspectives, and I could spend a lot of time talking about the impacts of cultural evolution, psychological norms, and all this sort of stuff. You can see they absolutely have all sorts of impacts on the future of human societies.
So what we thought would be extremely useful for others outside this room is, and first of all, for those here who want to think harder and deeper about these kinds of questions, I'm not sure we want to reach a common and I'm not sure we need or want a consensus. But what I think we do want is to be able to offer a more detailed characterization of what is individuality and what comes out of it from one perspective. How you cut the major transition depends, right? What you think major transitions to individuality depends on how you understand individuality. But in that group of thoughts, which will sit together, think, come up with something and tell us, we hope, I don't know, I hope, but I'm not sure anyone, that there will be more than one option. But it will be more clear what comes out of this understanding of individuality, what kind of tools you need, okay? How would you cut the major transitions? What comes out of a different understanding of individuality? We hope to be able to present this so that other people will understand what do these concepts mean? How are they related to certain mathematical models? Okay, what comes into your assumed parameters? But to be able to work on this, to think about this, to talk about this for the next day and a half or 2 days, and come back, we will have a few sessions that people will report on what is going on. And of course, no one has to come with anything unanimous, but things that interest you and that you would want maybe to write about later on. Okay, so I think these are excellent questions. These are exactly the things we're looking for. Questions that you would be interested in.
I guess what I want to do is just promote this idea that I'm completely on board with different perspectives and so on, but it's useful to know in advance what our own perspectives are. Those, I could just imagine being loggerheads, for example. So I'm not.
So I was saying there are two different perspectives.
Well, I guess
as you feel, one is more traditional, one is human oriented, and you're trying to understand which one we're
right, and so Claire also pointed out that there are kind of two different sorts of questions here. We can either lump them together and ignore them, Or we could say that there are two kinds of questions here. Maybe we should consider that before we decide what questions are going to be particularly interesting.
So what are the two questions?
Well, one seems to be the standard, what I think of as fairly standard perspectives, these evolutionary perspectives of what individuality is, from a Darwinian perspective, and how those hierarchical levels come about. There's lots discussed there. And then I might say, then there's the whole issue of what is perhaps special to human thought, to cognition, to symbolism, and the impacts of cultural evolution, I guess. And I don't necessarily see one. They're two different kinds of questions, actually. They impact on one another, but one could think about transitions in individuality from a very strict mathematical Darwinian perspective, functional, predictive, in the absence, perhaps, of thoughts about cultural evolution. I'm saying it's not relevant, but then there's another set of questions to say, if we're focusing particularly on humans and evolutionary transitions, right? And if from a Darwinian perspective, we see that the likelihood that human society undergoes a transition seems somewhat unlikely, then we shift our attention to particularly human-specific aspects, and maybe that focuses much more on aspects of cultural evolution, what we think about as individuality, in a different way than the levels of selection.
Okay, so how about this? That we first that's the idea of a brainstorming. Let's put first everyone, not everyone, everyone who wants to, kind of raise up his, not only his questions, but like you said so beautifully, where do I come from to this question? We'll have a range or a spectrum, or maybe different domains of questions, and only at the set we'll have coffee. And only later on, and during coffee, people will say, okay, so where do I want to go? And then we will see how many people are interested in this or in that. Personally, I think it would be extremely interesting if we come up eventually after the talk with something that most people think, and then another view that says, wait a minute, why all of you guys are wrong? And we will present that together. So we don't have to lump them. We can, in Judaism, in contrast, that debate is extremely fruitful. Okay? And since all of the people I met so far seem extremely fruitful, and I think it could work. Okay? These debates. So as much questions and as much background to each question, and I think let's just put them here and see what happens. Any other questions are welcome.
Thank you. Yeah. My question is, if we are in a transition, then in individuality, then which would be the next unit? I think that is an important.
The future.
Yes, which is the unit? Is a religious unit, a political unit, an economic unit, and why? What characteristics have this are particular to these units, and why do we consider this a unit? And the other one is, are we not in just one next level of transition? Is another level forming? Say, if we consider the city, the unit, cities are specializing in exporting goods, for example. And there is an enormous interaction between cities. So is this a next level above the level we're considering?
So if it's okay, I will lump these two within these questions about future. And maybe not, we can also ask questions about predictions. Are predictions at all? In what sense? Are they relevant? Are they useful? Okay? But this is talking about the future.
What was the second question? Can you say it again?
Is there another level beyond the next level we are considering? So we're considering a group of individuals like a superorganism. Are we in a transition to a further level, say a global superorganism?
Which? The last words? What's a
Global superorganism.
Like God. No, God is with all species. So.
One of the things worth remembering is that Darwin was led.
I think
The
it's not
mic is,
working.
Darwin, is it not?
It's not working.
Well, Darwin was led to many of his thoughts by the French and other European linguists who were classifying languages at the time. That was way before 1859. And one of the things that I think is really interesting is how cultural individuality, in the sense of linguistic individuality, is to some extent disappearing. We're in a transition from everybody, for example, in the last 50 years, look at how Hebrew has changed. With probably more than any other language. Probably because of the combined effects of 1967 and cable TV and those things. When I first came to Israel in 1965, very few of the teenagers spoke English. And that's true all around the world now. So it looks to me as though there is beginning to be, it may have already happened, a loss of linguistic individuality because of these media and the tools like computers, for example, have made a unifying technology that everybody knows.
Okay. So when we think about these problems and we really want to say something about humans, it strikes me that with due respect to ourselves, our workshop has been a little bit thin. It has been a little bit thin in terms of sociological, historical, politological studies. And that's a problem, right? It's not one human condition, right? I just want to remind ourselves again that, in the case of the hunter-gatherers, there was a rather strong egalitarian element. With the origin of agriculture, the society became hierarchical. And also, if you now consider the informational aspect, right? We mentioned language, but later, the origin of writing, right? The origin of printing, then, all the other information technologies that came have not only transformed cultural evolution, society, but if you look at the interaction patterns, they actually redefine units in terms of the hierarchy, because the interaction patterns have completely changed, right? So I am a bit skeptical whether we are really fully competent after this workshop, because these things should have been addressed, right? I mean, for example, if you consider that the combination of writing and the legal system, or the rule of law, which is so important in terms of historical thing. I mean, if you combine it with this idea that everybody should be equal in front of the law, at least in principle, it's again an incredible equalization force. And for those who are under the rule of law, that is obviously in many respects an extremely cohesive unit, right? And in another legal system, that's another cohesive unit, right? So the co-evolution of group structure with this information storing and transfer, this is why it was so important in the major transitions, but I think it's even more important for human society. And just to concentrate on this individuality aspect, without the information storage and information transmission and information expression aspect is lame, to be honest with you. I'm sorry. It's,
No, it's a good. What do you think about this? Okay, I think the criticism is totally accurate. But since
We surely acknowledge that we had struggled to bring in historians. We could not find anyone that would come on board.
yeah,
So
but
that's,
that's our fault. Like, but given who is here, and given your book that had two very different questions put together, right? And sometimes people conflate them. But the whole question of the mechanisms of storage of information and transmission, the storage and storage and transmission, at least in your book and in Ava's 94 paper, they kind of they move, they change when you have a new level of individuality. And can we say something like we characterize what is individuality? Can we characterize something about what would we expect, or what do we have to say in characterizing in storage and transfer of information to a new level of individuality, given what it is, and then we will try to apply it maybe to humans, okay? So that way we can say something that is general for our community, and someone else, who unfortunately we were not good enough to bring here, might do some work with it on humans.
I put what you've just said and what Ayelet said is written down here. Let me know if you find it relevant.
Yes.
As a question.
Yes. And something that I think both it was not discussed in this meeting. I know that both Ersh and I are thinking a lot about it, as usual from rather different perspectives, is learning. And how we can provide a unified kind of framework to the different levels of changes at the ecological level, at the neural level, at the phylogenetic level, by using what we know about learning theory. Because evolution was very often compared to learning, right? And in the sense that you have like trial and error, and then a stabilization through natural selection, and it's like reinforcement learning, and so on. And you can think about all kinds of strengthening of interactions through repetition, like in Hegel kind of systems, and so on. I think it's a very, very useful perspective that can also be used not only to show us the similarities, but also the differences. So Ersh was talking, for example, about evolution in the brain. That there are replication dynamics there, and this replication dynamics de facto leads to an evolutionary system within the brain itself, within the ontogeny of the individual. The brain is an evolutionary machine, so to speak. And there are all kinds of things we can say about this, but I think that the idea that we are also reaching new types of evolutionary dynamics because we're using different, not because the dynamics necessarily changes at the basic level, but because we're applying it at different, it is applied to different types of things, I think it's very important. It can tell us something about what is going on. I know it's something we did not discuss, but I think it is something that within the framework of this discussion about transitions, I think it's useful to think about that too. It's one of the few unifying frameworks that we have.
Can we, will you agree if we put, just like I think this is a really important question and relevant within the framework of speaking about the future and being able to make maybe predictions, would you agree that, does it make sense to you to say that a framework for learning is one way to look at mechanisms of transmission?
Yes.
And then we'll have this theme, and then both of you can be like in the same working group. I'm trying to operationalize for others what would we like, what we ask, what we hope will come out of here. not just people listening, people talking with each other in small groups and coming back to the group with their insights. Okay? Igniting others in different groups to think as well. We're trying a different dynamics of our workshop. It
Dan,
can fail, but maybe not.
Dan wanted to add something. Dan, can you hear us?
Oh, no, it's ancient history. That's fine.
Okay.
Question?
No.
Just hearing? Okay. Ah, okay.
So maybe it's a little bit of follow-up or reflection of the last 2 points. So when we talk about cultural evolution, we typically think about items of information that are transmitted among individuals. But of course, culture is itself a sort of an individual, right? So typically when we talk about, we want to move to that level, we move to a sort of group selection view, right? Where we sort of, and it occurred, I think, in several of the talks, we forget that we're talking about types of cultural individuals. We, again, are thinking about biological groups, and the information remains this informational unit. So if you think about cultural niche construction and so on, where a culture presents, the niches for other kinds of cultural items and so on, one might start reflecting, and this is like totally just occurred to me while people are talking here, where maybe we should at least try to reflect about levels of individuality of cultures, right? So as you have transitions, yes, right, from major transitions and so on, in individual, biological individuals, in cultural individuals, which may be, and I'm not saying I endorse this view, but it occurs to me that someone might, just like Paul, object to this idea or doesn't see any evidence for the idea that there is a transition in humanity's individuality on a biological scale, but there may be a change because of these cultural extinctions and so forth, the kinds of biological and cultural.
That's exactly what I have.
Okay, so
we don't need to have selection. We can't be there's another company.
sure, but just to clarify, I didn't mean just that we get more uniformity, which certainly happens because of all these things, but we may have new structural, types of culture, right? New arrangements of the heterogeneity that remains, that is enabled, and so on. Again, I'm just throwing it out.
Cool. No, great.
I have to say that I'm a little bit confused, and I'd like to suggest kind of a few questions just for clarity, because I try to understand what people here, or different people here, consider as a major transition or as a transition at all, and what is the difference between transition or any kind of radical or important evolutionary change. So just for example, I will not talk about you, talk about birds, because I like birds and then also about
You don't like you.
So for example, I will ask you, and I guess something will say no. Is the evolution of life was a major evolutionary transition? And I guess no, right? Yeah, okay. This is a simple case. Yeah. Although it was a major evolutionary change, it was not transition. Okay. Now, but if, for example,
It was an innovation.
Because I think the sound of what you talk here, they're not. There are many interesting stuff, but not everything is transition.
Yes.
The other case I will talk is that let's imagine now about
Just a
cultural.
second. Would it make sense just for you to develop if we so since you point on this crucial junction, maybe when we talk amongst ourselves and we join, I don't know, in a couple of hours, if we can clarify better what we mean by a new level of individuality, it will give us tools to decide, are we talking about a major change or innovation, or are we talking about a transition? So
Not necessarily, by the way. I think
not necessarily, but
two questions are overlapping, but
Yeah.
Exactly.
Okay. The more difficult is,
So
okay.
put another question.
okay, sorry.
The evolution of life is sort of the easy case, okay? The more difficult case would be now talk about cultural evolution in birds. Let's imagine the birds already have songs and they have song dialects, and let's imagine all the songs, it's all cultural, and all to start building tools like the Galapagos woodpecker tree, Finch, and they start to learn from each other how to build a nest, and they're completely dependent in the salt, in the food, in the nest. Okay, so in terms of cultural evolution, they are very, very, very well advanced. Is that already, I mean, so the unit of the replicator units are already means or socially, but not genetic. Is that already a transition? Here, some may say yes, some may say no. And the third level, I say, let's think about cooperative breeding birds. And we'll say that suddenly they become eusocial. So, for example, the helpers become really sterile, and the dominant pairs that will breed, like in bubblers or cooperative or stock jays, they will only be the reproductive caste. That would be a transition for the birds. And I guess some people will say yes, eusocial, this is transition. But I think these three things, I wonder what people think about it. Of course, when there is this, everything happened together. And I think for the human race, everything happened together. You have innovation, you have cultural transition, and you have also the idea whether we are becoming individuals, more kind of social or less social.
Yeah. Just one note about that, what I showed on the first day. So if you take the book of Burke, right? And this distinguishes between social group formation, social maintenance, and social transformation. And I said that people can be classified into whether they say that after the first there is the major transition, and the rest is just working out details. Whereas other people in the literature insist that it's just after the second column there. All right. So before, for example, you have really the origin of terminally differentiated, unmated castes in a social insect. That's the point of no return, as Boomsma, for example, says in his recent review. And the other cases which are very close, but they don't have this critical aspect, it doesn't regard as a major transition. So he puts the goalpost, very far. And I think we can. I don't think it's very useful to split hairs on this because it's a matter of choice. But we have to be clear about which one we mean when we talk or an individual talks. Then he has to make it clearly what interpretation he or she has in mind. I think that's more important than trying to wrestle endlessly.
So two things we can actually do with this. One is, when there's a group going to court, they established another group that is the Ibhamistawa group, and that's the group that challenges the first group. So these kinds of challenges, what do you mean by a major transition? I think are crucial for being able to answer this question about human culture. And either writing about specifically that, the challenges, or like giving examples. I think of Ofel's talk about ants, how relevant it is for me to think about humans and their collectives. Same thing when you rise about the questions you rise about birds. So I think it's crucial that we will not talk only about humans because we have tools to think about humans from other domains. And this kind of critical thought could be extremely helpful, I think. So it should come up again and again and again, either for someone to challenge oneself or as a separate chunk saying, look, the kinds of problems that we have to face.
I'm surprised that so far there's nothing up there about norms or institutions, and it seems to me we have a huge amount of data on that, and those norms and institutions are relevant to many of the other things that are there. I mean, if I were to ask what has been the biggest effect on English language in the last 1500 years, I'd say it was the Norman conquest of Britain, where Latin words came in to the language, where the meaning of words in English changed. Like words like gore, which before that meant farmer, and after the French invasion, it meant an uncouth individual. many words in English that change is because of the institutional change within the structure of England. And that happened in Italy with the Lombard invasion, where the language changed radically because of this institutional change. So whether you talk about law, as we just heard about the rule of law in England started with the Magna Carta. But immediately after the Magna Carta, English changed, the language changed. You started to get words like confirm, allege, claim, what I call speech act verbs, because you had lawyers. And the way in which they talked changed the English language. And it wouldn't have happened without lawyers, which were the Magna Carta.
וגם דוגמאות נגד, כאילו, what are not just a counter examples. Any other questions you think might be relevant? These are what?
Kind of a fun perspective might be to ask what would be necessary, what conditions would be necessary or could facilitate a Darwinian transition in individuality at the level of a human society, but equally apply that to thinking about ideas, cultural ideas, normatives, and so on. So that,
Just could you repeat the last part? What conditions would be necessary sufficient?
Insufficient to facilitate a transition in individuality, I mean that in the Darwinian sense, at the level of humans or human societies or cultural groups.
And how to avoid it.
What conditions would, and then how far away are we from those?
We had here, we were presented with models, and I want to ask a question whether models that are based on population genetics, extended of course, and so on, are the best models that we can use for cultural evolution. Maybe because cultural system is a system, maybe systems biology can offer, although it is a rather unsatisfactory stage in some ways, it can still offer some tools, additional tools to, of course, I'm not saying that the population genetic level is not good, but maybe there are other ways of trying to model human cultural evolution, cultural systems.
Other models. New synthesis model, what is it? Genetic population model. The best way to think about transition and cultural transitions in here. Any more?
One class of additional models.
I would say mutually. Epidemiology, justice, and then can combine with it.
Maybe just to add, or even to ask a question, please, or it might be this, maybe just, or it might be necessary actually to add explicit models of learning, social learning for cultural transmission. Because I can say something, I learned, for example, when I came as a behavioral ecologist, worked with Feldman, I learned that actually genetic mechanism might be important for the thermodynamics. But what in my work with Mark, showing him is actually explicit modeling of the learning process is also important for something because the trade-offs and prospects of exactly using this process. Yeah.
And not epigenetics, epidemiology, the epidemiological.
I don't have a question, but it's more like in general comment, I guess. It looks like if you want to stay within the framework of major evolutionary transitions, it's not if it's still supposed to be a unified scheme. It looks like there are three approaches. Yeah, if we do it, if we stay within major transitions, it looks like there are three different approaches or preferences in this group. One might be just to look at biological approach at individuality levels of selection, and biology scale. Alternatively, I kind of would then look at cultural evolution and try to see if there's anything in the ongoing cultural processes that modify or be close to that. And the third one is actually kind of take to the extreme the claim that humans are going indeed through major evolutionary transition and kind of look at the future. Let's kind of, if we, again, if let's stay within the concept of major evolutionary transition. For example, if we want to talk, if we don't want to focus on that, there's a lot of questions about culture. Again, about learning, about social norms. And there's enormous diversity in the same biology.
Right. I think it's a good idea. We can use it to put these questions into three domains. Of course, you will not be restricted. You can mark your name near any single question. But for us, it's easier if we cluster those questions into those domains.
Changes, cultural changes,
and the future of future of humanity.
I mean, animals have culture too, right? So most of them, I guess, I think that's a really good point. And obviously, those are three distinct things, but cultural evolution is approach animals.
I totally agree. I really hope we will not talk, when we talk about culture, even morally, don't want to talk only about humans. Sorry. But yeah, I think there should be, we have tools for the animal, and yeah. So the cultural domain should bring in tools and models and I had the other good one that I don't know how to pronounce well, so I just checked. Geez, any more things that you, but click on you didn't talk before.
Maybe whether we can design an ecology that favors cooperation, peaceful coexistence for them.
Favors what? Say the last words.
The favor cooperation, coexistence, peaceful coexistence.
Peaceful coexistence. It's a valued judgment. Okay.
Wow, cooperation also. Almost every term we use here has values and trends.
So one thing that I think came up in talks, two related things. One is transitions, because you can go back and forth. So species, we have examples of species, related species, one eusocial and the other not, but also cases in which it depends on such a situation and so on, which we not call them major transitions, but they're sort of, what's interesting is that they're big quantitative changes, but they are reversible. And this is related, it's not necessarily the same thing as just marginal cases. You use such terminology such as Dr. Smith's, right? So it's not really a transition per se, because not all the conditions are satisfied to the highest degree that you need, but you're very close to it. So we have these situations in which the environment determines the group, and so on. So just trying to sort of understanding better what we mean and what kind of example cases we should have in mind might be helpful for some of these more semantic or not semantic abilities.
So I heard two things. First, marginal cases of transition, of major transition. Second, good examples, or a set of in philosophy examples are really crucial, right? But to bring into the table good examples for all of the different settings that we're thinking of.
It's not a separate topic, right? It's a direction for each group, each question.
No, what I meant is that the way some of these questions are phrased and some of the discussion was phrased was whether something is a transition, which seems to suggest sort of a yes-no answer. Whereas if you start thinking about cases that are more or less like a transition, it's sort of a different framework. So whether we should include in our thinking marginal cases, I think is a separate question. The answer may be no, and then you don't need to do it for the entire, all the rest of the questions. If you think marginal cases are important, then maybe they are important everywhere. I don't know. I see it as a separate issue.
I'm not sure whether it should be a question by itself, but I think it's not quite clear what is it to be human. We take it for granted. Maybe it's a different question. It's just whether being human is a transition. If it is, then in what sense?
So, thank you for your patience. Soon we will reach you out.
So this is probably not the question that maybe okay, much interest here, but I'm interested whether we can learn anything from these more superorganismic species in terms of how to manage human affairs, because they have gone farther in cooperation. They are blueprint for cooperation. And so, for example, when I was talking this morning about the ants carrying the load and deciding on the direction to take, this is collective decision making, and it is something I actually teach teams, like how to get the best out of your team, how to make the best decisions. And ants probably have found the right way of doing that. And is there maybe something we could take from that context and tell humans, here is a better way of doing it, or here is a more optimal way of making decisions? And decision making is only one context. So is there anything we could learn from this species that we could apply in human context?
So did that.
Now that you mentioned this marginal transition idea, I think that is an important one. But I think, especially for the comparative approach, one can complement it with a number of others. So I mentioned this case of what I call the limited transitions, which are not marginal. If you look at them individually, they can be complete. For example, the separation of soma and germ within the ciliates. But I don't regard them as major because the impact that they had on the rest of the biosphere is, it's very limited. So those are the limited transitions. Then you have what I call the recursive transitions. For example, a recursive transition is when you are making a new multicellular organism, but the unit from which you start is already a multicellular organism. So not a colony. That's the case in the case of scyphozoans, for example, when the individuals that were individuals before were more or less like organs, but still it's a multicellular organism or that's a kind of a recursive transition, right? And the same you find in the plant world, where you can have secondary and tertiary plastids. That's again a recursive transition. And then the final category in this is the repeated transition, where you have another try. I mean, you are successful. So you had this, for example, for many times for multicellular, but also, for example, for the origin of plastids, there is a de novo origin in the case of Paulinella, where another cyanobacterial inclusion actually seems to repeat what happened 2 billion years ago. So there's a repeated. So these are different categories, and I think they are important because you can learn from each of them. This is what I want to say.
מבינים בקטגוריות של Okay. How about tools? So the discussion so far was very conceptual, but this one, when I look at the biological literature, you can make progress without mathematical models. Darwin was okay, but having a tool at your side makes a huge difference. So maybe if we don't just think about cultural evolution, but try to think also about the different mathematical tools we have today, can we say something about them? Are there something that is common, trying to look at the types of tools that we have? How far do they take us? Are there embedded limits within them? I don't know enough mathematics to do any of this, but I wonder if that would be of interest to people here to think also about tools for modeling transitions, not just about saying what they are. There are other questions that people want to ask. Yeah. Okay, so I think what we should do now is we will sit here and try to categorize it into these 3 clusters that Sergey offered, and put different questions and put questions that don't fit in any of the clusters. We highly invite you to suggest other things that interest you in particular. Because the talks are so good that I'm sure, even if it doesn't really fit you well, it's worth having a discussion at least here in the small group, and then when you will write whatever you want to say, and we'll dissolve into small groups. Okay.
So many questions. 1.4 questions per person here.
Okay, but first we'll have coffee. We'll set it into categories, and then we'll invite you to see what you like. Or suggest something new. So coffee.
For how long? Just make a motion. Including coming back here and marking your name and some questions. No, before. Before coming, 25 minutes. No, 30 minutes. So, it's basically 5 o'clock. 5 o'clock. Yeah, 5 o'clock. And 6 we have
Just a bit more precise. I don't have courage to come. Dan, we're finishing the session.
עכשיו, השאלה היא ככה, בואו נעשה את זה עם רווחים.
Make sense for me to try to participate in the group, so I'm going to step out now.
Dan, can you hear me?
Can you hear me?
Yeah.
Okay. I said, I don't think it makes sense for me to try to participate in the groups, so I'm going to step out now.
One second, I put
Okay.
Situation, say, I wonder if that's undergone a transition. And then you could look at it and you could say, to what extent do I see offspring based?
Can you hear me better?
Yeah. Okay.
Okay.
So I don't think it makes practical sense for me to participate in the groups, so I'm going to step away now. But
Okay.
thank you for making all this happen.
Sure, you're welcome. The talks from today are already on the website.
Yep.
So
And I think there's one more talk. Is that right?
yeah, there is Peter Koenig. It will happen in 1 hour.
Okay.
1 hour, 1.5 hours.
Okay. I'll be back for that.
Okay. See you then. Bye then.
Thank you, Tamer.
You're welcome. Bye bye.